Okay, so here we have a tangent line PQ. So right here you can see this is P, and here we have Q. So tangent line PQ, and P is an external point to a circle that has radius as O. And here, if we connect P and O, the point of intersection is T. All right. So what they want is this, or what the question wanted, is a CBSE question, that if the measure of PQR is 110, let me change the color here, sorry about that. Okay, so if this measure is 110 degrees as is given, then we have to find these angles alpha and beta. Okay, so let's just go for them. Alpha would be easy. Why? Because you can notice this. Here we have radial line meeting the tangent line. So this angle is going to be how much? That angle is going to be 90 degrees, right? And here, this angle is going to be how many? 70 degrees. So alpha will be, and let me erase this here because I just messed up this here. So what alpha will be then? Alpha will be 90 plus 70 is 160. So if I subtract 160 minus 180, that will simply be 20 degrees, right? So alpha becomes how much? 20 degrees. So at least this part is done. Now we have to determine beta. And that doesn't look that simple or straightforward. So how about this, that we do this? Let's just go ahead and use everything that I know, that we know rather. Okay, so here I am going to, why are you doing this to me? I'll just use my pen. Okay, oh no, that's okay. I can still use that a little. Okay, so I am joining these two. All right, so they are joined, and then I'm doing this. There are two other right triangles that are in there, because remember this, that if you go ahead and make a triangle in a semicircle, all right, then with diameter as the base, let me not do it this way, then that becomes a right triangle, right? So this triangle is a right triangle, and likewise, if I make a triangle here, just a moment, don't do that. And how do I change the color of this? It's okay, don't worry about it. So here is this, and then we have what going back here. I'm just getting used to this new drawing board. And then what I'm going to do is just finish this. Okay, all right, so we have two right triangles here that are, that are made in those semicircles with the diameter as the base. So let's see how many properties we got. We got this, and there's one more thing that I forgot to make. Okay, you had suggested this. I'm just rewriting this for you. So right here, we can join these two. So we got a bunch of isosceles triangles and right triangles and everything. So let's go ahead and get back to work. Okay, so I am, just to distinguish those, the right the right angles that I made, let me just make them by purple color. Okay, and purple is not really that distinguishable here. So how about changing to a different color, which will be like, yeah, here. Let me make those orange. All right. So these orange angles are 90 degrees angle. All right. And moreover, what you see is this, that this and this and this, they are radii. So they're going to be congruent. So we got, actually here in this case, we got three isosceles triangles, right? One of them is this, another one is this, and the other one is this. So it appears that we got a lot more than we really need. Okay, so, and this question is framed as an algebraic question, so we will partially do it algebraically. So let's let this angle be theta. Let's let this angle also be theta. Okay, then what this angle will be? Okay, this angle will be, I just want a different color for that angle. So this angle here would be how much? 180 degrees minus, I hope I didn't make it too light for you. There, theta plus theta, okay, plus 70 degrees, and it is really too light here. So that will be 110 degrees minus 2 theta. Let me write it a little darker. So this is 110 degrees minus 2 theta, right? So that's what this angle becomes, the angle right here. And then notice this angle is how much? This big angle is beta and the red angle is theta. So this is beta minus how much? Theta, right? And since this side is congruent to this, we got a beta minus theta here as well, right? Now remember this property, that this external angle is going to be the same as sum of these two internal angles here. So what we mean by that is this, that if we take beta minus theta plus beta minus theta, then that equals how much? That equals this angle, which is how much? 110 degrees minus 2 theta. And this is a really lucky equation that we are landed on, or we have landed on. And then we get 2 theta again here, theta, and these guys will cancel each other. So we got 2 beta equals 110 degrees. So beta would be how much? 55 degrees. And that's what the answer is. So actually I went ahead and just panicked and made a lot more construction, and that's how we had started. All I'm doing is summarizing our earlier discussion. And so what did we conclude now? We concluded this, that alpha equals how much? 55 degrees, and beta equals how much? 20 degrees. Okay,